Looking at the map right now, we're tracking an active frontal system that's positioned right over the central United States. This is a classic mid-latitude cyclone setup, and it's creating a pretty sharp divide across the region. What we're seeing is two very different air masses coming face to face, and that transition zone is stretching from the northwest all the way down to the southeast. Let me walk you through what's happening and what you need to know. First, let's talk about the overall synoptic picture. This frontal system is bringing together a cold sector in the north and northwest, and a warm, humid sector in the south and southeast. That contrast is what's driving everything we're seeing right now. The temperature differences, the wind shifts, the changes in precipitation type from one region to another, it all comes back to this fundamental setup. And when you have two air masses, this different sitting this close together, the atmosphere doesn't stay quiet. It reacts. Now, let's focus on temperatures, because this is where you really start to see how sharp this divide is. Right in the center of the map, we're seeing readings around -2 degrees Celsius, which tells us that cold sector has already pushed into the Missouri and Iowa area. If we break this down by region, here's what we're looking at. Up in the northern states, places like Minnesota, Wisconsin, the Dakotas, and northern Iowa and Nebraska, temperatures are below freezing. We're talking about 0 Celsius and lower. That's snow territory. If precipitation is falling in these areas, it's coming down as snow and it's going to stick. Further south, in the central transition zone, which includes northern Missouri, southern Iowa, and western Illinois, temperatures are hovering right around the freezing mark. That's the tricky zone. This is where precipitation type can change rapidly. You could see snow, then sleet, then a mix of snow and rain, all within a short period of time, or even a short distance. It depends on exactly where that cold air is positioned at any given moment. Then, as we move into the southern and southeastern states, Arkansas, Tennessee, Kentucky, eastern Oklahoma, temperatures are above freezing. In these areas, we're dealing with rain, not snow. The fact that temperature is changing so quickly over such a short distance tells us this frontal system is strong and it's active. The gradient is steep, and that means conditions can shift fast. Next, let's look at precipitation and lightning activity. The rain and lightning map shows us that precipitation is organized in bands and clusters along this frontal line. It's not evenly distributed, it's concentrated in specific zones, and that pattern tells us a lot about what's happening in the atmosphere. In the snow zone, which is that cold sector we just talked about, we're seeing snowfall across Iowa, northern Missouri, western Illinois, eastern Nebraska, and northern Kansas. If temperatures are at or below freezing in these areas, the precipitation is falling as snow. Up in Minnesota and Wisconsin, the snow is likely more steady and persistent. This isn't just a quick passing shower, it's organized, and it's going to last for a while. Then we have the transition zone, that mix area in southern Iowa, northern Missouri, and western Illinois. This is where things get complicated. Precipitation type can change within minutes. You could start with snow, transition to sleet, and then maybe see a mix of snow and rain. That makes travel particularly tricky because road conditions can deteriorate quickly. Sleet and freezing rain are real concerns in this zone. Further south, in Arkansas, Tennessee, Kentucky, eastern Oklahoma, and northeastern Texas, we're dealing with steady rain. And along that frontal line, we're also seeing localized intensification. Some areas are picking up heavier bursts of rain, and there are even a few lightning strikes showing up. That tells us there's some instability in the atmosphere. Where you see lightning in a winter system like this, it usually means stronger updrafts and potentially heavier precipitation rates. Now let's talk about the wind, because wind is a huge part of this story. The wind field on the map confirms the structure of this frontal system. In the warm sector, to the south and southeast, winds are coming out of the south or southeast. That's bringing moisture northward from the Gulf of Mexico. That's why we're seeing all this precipitation. The Gulf is the fuel tank for this system. In the cold sector, to the north and west, winds are out of the west or northwest. That's pushing cold air southward. And right along that transition line, where these two air masses meet, we're seeing wind direction change and wind speed increase. When the pressure gradient is tight, which it appears to be, wind gusts can reach 25 to 40 knots in some areas. That has consequences. In the snow zone, it means blowing and drifting snow, which reduces visibility. On the roads, that can be dangerous. In the rain zone, it means those rain bands are going to move through quickly, and some of the heavier cells could produce gusty winds as well. The satellite imagery backs all of this up. When we look at the satellite structure, we're seeing a classic mid-latitude cyclone signature. In the northern sector, there's a broad, homogeneous stratiform cloud deck. That's consistent with steady snowfall. Along the frontal line, there's a thick, elongated band of clouds. And in the southern sector, the cloud structure is more fragmented and convective. That matches up with the rain and lightning we're seeing on the radar. This is exactly what you'd expect from a system like this. Now, let's talk about the role of the Gulf of Mexico. The moisture being pulled up from the Gulf is a critical part of this setup. That Gulf moisture is feeding into the warm sector, and it's sustaining the precipitation. The more moisture that gets pulled in, the more persistent and heavy the precipitation becomes. If this system continues to tap into that Gulf moisture as it moves, we could see precipitation totals add up, especially in areas where the rain has been falling steadily for hours. As this system moves east, which it will over the next 12 to 24 hours, we need to watch what happens along the Appalachian Mountains and the east coast. If the cold air stays locked in place over the interior and this moisture pushes up against the mountains, we could see significant snowfall in the higher elevations. Closer to the coast, where temperatures are milder, it'll stay rain, but that transition zone between rain and snow could set up right over areas like West Virginia, Western Virginia, and parts of Pennsylvania. That's something to monitor closely. Let's talk about the timing. Right now, as we move into the evening hours, this frontal line is active over the central states. The snow zone across the northern and central transition areas is likely to hold strong or even intensify through the evening. South of the front, those rain bands are going to continue pushing eastward. And as the system progresses, we're going to see that wind shift. When the wind direction flips, that's your signal that the front has passed. Behind the front, temperatures will drop, and any lingering precipitation will likely change over to snow in areas that are close to the freezing line. Now let's talk about the risks and impacts, because that's what really matters. If you're in the snow zone, the combination of snow and wind is going to reduce visibility. Blowing snow can make driving hazardous, and snow drifts can develop on roadways, especially in open, rural areas. If you're planning to travel tonight or tomorrow morning through areas like Iowa, northern Missouri, or western Illinois, be prepared for winter driving conditions. Give yourself extra time, reduce your speed, and make sure your vehicle is ready for winter weather. In the transition zone, the risk is sleet and freezing rain. Even a light glaze of ice can make roads extremely slippery. Bridges and overpasses freeze first, so be especially careful on elevated roadways. If you're in southern Iowa, northern Missouri, or western Illinois, monitor conditions closely. If you see sleet or freezing rain start to fall, it's best to delay travel if possible. In the warm sector to the south, the main concern is heavy rain and localized strong gusts. If you're in Arkansas, Tennessee, or Kentucky, keep an eye on the radar. Some of those heavier rain bands could produce brief periods of intense rainfall, and that can lead to localized flooding, especially in areas with poor drainage or near small streams. The wind gusts associated with those stronger cells could also knock down small branches or cause brief power interruptions. So, putting it all together, what we have here is an active frontal system over the central United States. The northern areas are dealing with snow, the central transition zone is dealing with a mix of snow, sleet, and rain, and the southern areas are dealing with rain and occasional thunderstorms. The temperature contrast is sharp, the wind is active, and the satellite structure confirms that this system is dynamic and still developing. Over the next several hours, conditions are going to remain variable across the region, and some zones could see more intense weather. For those of you in the Great Lakes, the Ohio Valley, or the Mid-Atlantic, this system is going to be moving your way. As it progresses eastward, you're going to start feeling the impacts. Depending on where the cold air sets up, you could see snow, rain, or a mix. Wind is going to be a factor as well, especially as the system strengthens. Keep an eye on updates and be ready for conditions to change. The key takeaway here is that this is an active, evolving system. The atmosphere is not in a calm state right now. We've got strong temperature contrasts, abundant moisture, active winds, and a well-defined frontal structure. All of those ingredients together mean the potential for impactful weather is high. Whether that impact comes in the form of heavy snow, icy conditions, or heavy rain will depend on where you are and how this system continues to develop. But one thing is certain, this is a system worth paying attention to, and conditions are going to remain dynamic over the next 12 to 24 hours.